Okay, now let's look at example 10. The surface of a lens is coated with a film of magnesium fluoride which has a refractive index of 1.38. The refractive index of the material of the lens is 1.67. Okay, so now we have lens coated with magnesium fluoride di mana N is equal to 1.38 and then the lens N dia adalah 1.67. Okay, so now dia sama juga macam yang example 9. We have lens. Okay, di mana kita ada lens. This is the lens. And then di atas dia adalah coated with this one, magnesium fluoride. And then we know that light will travel from a medium of air. So that will be the light. Okay, so let's do this one again. So we have air here. And then dekat tengah will be the coating. Then dekat bawah will be the lens. Di mana air N is equal to 1. Coating N is equal to 1.38. And then lens N is equal to 1.67. Okay, before that, let's label dahulu. So N1, N2, N3. And then again, we have light, okay, coming from the medium of air, and then dia akan refracted apabila dia sampai dekat permukaan coating, and then dia akan tembus lagi, dan dia sampai dekat permukaan lens sebab dia they have different refractive index. That's why the light will bend. Okay, will look something like this. Okay, so we have ray 1 and ray 2. Okay, untuk ray 1, okay, N1 is less than N2. And then untuk ray 2, N2 will be less than N3. Okay, so remember kalau N1 less than N2, maksudnya daripada less than, so here less dense to denser. Daripada less dense to denser medium, there will be a change in phase. So PC, maksudnya there is a phase change. So ada kedua-duanya akan ada phase change. So remember kalau ada dua phase change, dia akan cancel out each other. So meaning that here, there will be in phase. Okay, which is 0 lah. Okay, so kita tengok balik kepada jadual. So we have in phase here, right? So we either use this one or this one. So depending on the keyword. So next keyword, adakah keyword dia bagi dekat sini? Okay, so kita tengok soalan yang pertama. Calculate the three lowest value for the thickness of magnesium fluoride film that would result in destructive interference. Okay, so this one dia sudah bagi. Okay, clearly dia adalah destructive interference. So meaning that, okay, tadi kita akan guna untuk in phase and then destructive. So we are going to use this formula 2NT is equal to M plus 1 over 2 lambda. So formula yang kita akan gunakan adalah 2NT is equal to M plus 1 over 2 lambda. So this formula, because it is for destructive, and then it's given here wavelength adalah 450 nanometer. Okay, and then dia cakap 3 lowest value. Okay, 3 lowest value bermaksud kita akan ada 3 value for the thickness, di mana M akan sama dengan 0, 1 dan 2, because we want the 3 lowest value, which means 0, 1 dan 2. Okay, so now let's do the first one, di mana M adalah sama dengan 0. So 2NT is equal to M plus 1 over 2 lambda. So N yang kita gunakan sebab dia minta thickness dekat magnesium fluoride, which is dekat sini, dekat tengah. So 1.38 T, and then M adalah sama dengan 0 plus 1 over 2, and then lambda is 450 exponent negative 9. Okay, so T will be equal to 8.15 exponent negative 8 meter. Okay, and then the next one will be M sama dengan 1. So, masukkan guna formula yang sama, tapi M kita akan berbeza. So, 1 plus 1 over 2. Lambda will be 450 exponent negative 9. So, you will get the T will be equal to 2.45 exponent negative 7 meter. So, label kat sini 1, di mana M adalah sama dengan 1. This one kosong. And now we want M is equal to 2. So, 2 times 1.3 at T sama dengan 2 plus 1 over 2 times with lambda. So, you get T2 will be equal to 4.08 exponent negative 7 meter. Okay, so that would be the first question. Okay, so second question. Okay, if the thickness of the film is the second lowest value calculated in A above, for what wavelength of the light reflected from the lens will constructive interference occur? Okay, so kita akan gunakan thickness di mana untuk second lowest value. Okay, second lowest value which means it will be 4 M sama dengan 1 because this one adalah second lowest value. And then dia minta wavelength. We want the wavelength. Second lowest value meaning that M sama dengan 1. Then we want the wavelength apabila constructive interference occur. Okay, so still kita adalah masih lagi di in phase. Tapi now we want to do the constructive interference, which means okay, in phase constructive. Okay, so we are going to use this formula. Okay, so soalan B. Okay, since it will be for constructive, and then the formula that we are going to use is 2NT is equal to M lambda. Okay, dan M yang kita akan gunakan adalah M sama dengan 1. Okay, because and we want to find lambda, right? Okay, so just masukkan 2N still sama 1.38, and then T adalah di mana M sama dengan 1, which is this one, and then T yang ni kita akan gunakan 2.45 eksponen negatif 7 sama dengan M adalah 1 and then lambda. So lambda will be equal to 676 nanometer. Okay, so this will be the solution for example 10.